G'day guys and welcome to this video for the 2014 Year 9 Numeracy Calculator Allowed NAPLAN Papers. Whoa, that is long. My name's Darren, Maths Guru. Really good to see you. If you can, subscribe to my YouTube channel. Head over to mathsguru.com where you can see loads of videos on all sorts of math topics and tell your mates. Alright, let's see where this one's going to go. A total of 301,617 babies were born in Australia in 2011. Of these, 146,621. How many boys were born? Well, I'm going to do 301, 617. I'm going to subtract from that 146 and 621. Now, while you can't see my calculator, I guarantee that I'm doing it. That gives me 154,996. That's my first value. Rose tosses a fair coin 100 times. Well, if it's fair, it means the probability of getting a head is a half and a tail is also a half. Which of these results is most likely? Well, if it's fair, we're going to get roughly half heads and roughly half tails, which would suggest that 53 heads would be the one. That's testing your understanding of, yes, fairness and coins and probability. Table shows some information about Australia's 10 tallest structures. How much taller than Melbourne's tallest structure is Sydney's tallest structure? Okay, so let's find Melbourne's tallest structure. So Melbourne's tallest structure seems to be 297. And then Sydney's tallest structure seems to be 309. How much taller than Melbourne's tallest structure is Sydney's tallest structure? So if I now do 309 and I subtract from that, he says, putting his calculator 309, subtract from that 297, we are going to get the grand total of 12 meters. Oh, he says doing it in highlighter. Let's just color that in. Tina walks along the path from X to Y. How far does she cover in kilometers? Right, well, basically what we're told is that distance there, so 1 square across is 100 meters, and it's also telling us that 1 square up is 100 meters. That's what that information there is. It's a key. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 squares in total. So 13 squares times that by 100 gives me 1,300 meters, and because it wants it in kilometers, we would then do that divide by 1,000, because there's 1,000 meters in a kilometer, which gives me 1.3 kilometers. That's a conversion thing. We need to know our conversions, guys. In which of these are two triangles shaded the same size and shape? Okay, so basically they're saying here they are congruent. It's literally, I think the question wasn't necessarily worded particularly well. So if we look at the shaded triangles in each of these diagrams, which of them are the same size and shape? Well, basically we can see for a fact that they aren't the same size. They are definitely not the same size. These here are not the same size as far as I'm concerned. I would say that one there was the same size and shape. Which number shows 3,000, 3,000s, 5 tens, and 2 tenths? Well, if we do a decimal point here, this is my, tenths, this is my hundredths, this was my units, tenths, hundredths, and thousandths. So let's just see what we come up with. So we want 3 thousandths, 5 tens, and 2 tenths, and where we don't have any numbers, we're going to put a decimal point in. So 3050.2, 3050.2. Two arrows show points on this number line. Which of these numbers lies between the two arrows? Well, let's have a look. This is about, so this is 350. That is 450. So let's say that's about 470. Let's say that's about 370. We're looking for numbers about between those, which is sort of going to be here. What do we reckon? 400 and something? Well, actually, no, that's not quite what it's asking. See, I thought it wanted halfway between, but it didn't. It just wants to know which one of these numbers falls between. All right, so it was a lot simpler than the before. All right, so it can't be 350. It can't be 490 because that's close to 500. It can't be that one. So it's 390. I wonder how many people got tricked on this one. On the extra exam. Mia measures 3 angles in a block of land. She makes this sketch. What's the size of angle X? Because this is a quadrilateral, there are 360 degrees in it. So I'm going to take away the angles that I know, 82, 56, and 104, and that will give me the size of angle X. So let's do that. 360, subtract 82, subtract 56, and subtract 104. It gives me 118 degrees. Loving this so far. It's going to get harder. In Australia, road distances are measured in kilometers. In the USA, road distances are measured in miles. 5 miles is about the same as 8 kilometers. All right, how many miles is 120 kilometers? So what I'm going to do is for every 8 kilometers, there are 5 miles. So I'm going to find out how many 8s go into 120. So 120 divided by 8. So if I do 120 and I'm going to divide that by 8, that's going to give me 15. Right, so there's 15 lots of 8 in there, which means I want 15 lots of 5 to tell me how many miles, right? So I times that by 5, it's going to give me 75 miles. Okay, happy? If you're happy and you know it, clap your hands. I see that one to my daughter a lot at the moment. Okay, Indra is shading squares in this diagram to make a pattern. He needs to shade some extra squares so the dotted line will be a line of symmetry. Ooh. What is the smallest number of extra squares he would need to shade? Okay, so for this to be a line of symmetry, this square here would need to be shaded to match this one here. This one here would need to be shaded to match this one here. And then what would we need? We would need this one here to be shaded as well. And then that would give me my line of symmetry. So it would be 3 extra squares. Which of these best describe the chances of an event that is very likely? Okay, so because it doesn't say certain, I think the language here is not 1. I think that's a trick. I think it's very likely we're looking for a number that's closest to 1. I don't know about you, but if I know my fractions, it's going to be 5/6, because that number is much closer than 1/3. Now, if you want to know why, you can convert all of those to 6. That's actually 6 on 6. This would be 3 on 6, and that would be 2 on 6, and which one is the biggest, but not 1? It would be 5 on 6. Wheelchair access ramps have a rise of 1 meter for every 14 meters of base length. So what that means is for 14 meters that way, it goes 1 meter up. There we go. What is the base length for a ramp of rise 0.4 meters? So what I actually need to do is if I multiply that number there by 0.4, then I will get 0.4, and then to keep it so that they're similar, we would multiply that by 0.4 as well. So I'm going to times that by 0.4, which is going to be 5.6 meters. Job done. Sue has only 10, 20 and 50 cent coins in her pocket. 10, 20 and 50 cent coins. In total, she has $2.80. What's the smallest number of coins she could have? Okay, well, first things first, 50 cents. How many 50 cents are in there? So that will give me $2.50. So if I do $2.50 in 50 cents, that's 5 coins. It leaves me 30 cents. So there's a 20 cents and a 10 cents. 5, 6, 7 coins. I think 7 is going to be the smallest possible number of coins she's going to be able to have there for $2.80. 5, 10, 15, 20, 25. Yep, 30. There we go. Paul takes part in a swimathon to raise money. He has 2 sponsors. His father donates $2.50 for each lap of the pool that Paul swims. His grandmother donates 10 in total. How many laps does Paul swim if he raises $100? Well, we're going to do the 100 and take away the $10 from his grandmother, which means that he got $90 from his father. $90. If I divide that by $2.50, so 90 divided by $2.50 gives me a total of 36 laps. Danny earns $45 for washing 9 cars. $45 for 9 cars. Which expression shows how many dollars she will earn for washing N cars? All right, so in which case, she got $45 for 9 cars. I want to do 45 divided by 9 and then times it by N. Because if I do 45 divided by 9, that's going to give me how much she charges for each car. Okay, and because we're then doing N cars, that would be the right answer. So it'd be 45 divided by N, divided by 9 times by N gives me that last answer there. The indicator measures the depth of water in a lake or a lake. What is the depth of the water? All right, so what we've got to do is try and work out what the scale of each of those are. So if we look at the difference between 6 and 5, we notice there are 1, 2, 3, 1, 2, 3, 4. Goodness gracious me. I'm actually going to zoom in because my eyesight is not good. 1, 2, 3, 4. So there are 1, 2, 3, 4, 5 gaps. So each of those is worth 0.2. So each of those gaps is worth 0.2. So if we look at the 1, 2, and we've got 3 gaps there. So we're going to do 5, but we're going to take away 0.6, which gives me 4.4 meters. All right, so zoom back out, 4.4 meters. Notice it was a trick. Lots of people, I imagine, would have done something like 5.6. It really isn't 5.6. All right, let's see. On this map, the distance from the rocks to the water hole is 4 centimeters. What's the actual distance from the rocks to the water hole? Now, what they're saying here is, again, it's another scale. If you understand scales, it means for 1 centimeter in real life, there are 20,000 centimeters. Again, for 1 meter is 20,000 meters. It's awesome. I love scales and maps. All right, what's the actual distance from the rocks to the water hole? Well, because we've got 4 centimeters, that means you'd have to times this by 4 to give me 80,000 centimeters. And I imagine it wanted in meters. And we know there are 100 centimeters in a meter, which give me that there would be 800 meters. And obviously in that situation, if you'd pretty much got that first answer, or you'd done the conversion right, you probably would have been able to guess. Andy and Cal ran a race together. Cal finished the race in 1 hour and 5 minutes, so 1 hour and 5 minutes. Notice what I do. I copied this stuff down just to help me. Andy took 35% longer than Cal. Approximately how long did Andy take to finish? Well, it's 35% longer. First thing I'm going to do is turn this into minutes. So that's 65 minutes. I'm going to work out what 35% of that is by doing 35 divided by 100, all right, times 65. So 35 divided by 100 times 65 is going to give me 22.75, right? And that's how much longer it took. So we have to add that onto my original value. So we have to do 1 hour and 5 minutes. We're going to add on that. So we're going to get 65 plus 22.75. Add that onto my value. It gives me 87.75, about 88 minutes. And there we go. Well, these triangles are not drawn to the same scale. Which of these has an area of 36 centimeters? Well, if you remember, the area of a triangle is a half base times height. So whatever my base is and my perpendicular height, multiply those two together and divide by 2. Well, 6 sixes are 36. So this one here will be 6 times 6, which is 36. But when you divide it by 2, you're not going to get 36. So it's not this one here. He says not being able to draw through. This one here is going to end up as 6 times 12 divided by 2. Well, that is going to be, actually, interestingly, 6 times 12 divided by 2 gives me 36. Ka-ching. We'll just check the other ones. If we do this one here, it's going to be 36 times 1 divided by 2. That's not going to be right. And this one here, ooh, that's disgusting. Just even trying to think about that one's going to give me a headache. This table gives information about 2 drill bits with similar diameters. 1 inch equals 25.4 millimeters. What is the difference in millimeters between the 2 bits? So because we have 1/8 of the inch, so we can do 1/8 of 25.4. All right, so of in maths is times. So 25.4, in this situation I can just divide by 8, which gives me 3.175 millimeters. That's 3 millimeters, and because it wants the difference in the millimeters, I'm going to do that. So take away 3, and then it says, give you an answer to 3 decimal places, 0.175. So Bill is standing 5 meters due north of Sarah. So here is Bill, and here is Sarah. Okay, we got that one. And Sarah is standing 5 meters due east of Alice. So Alice is here. There we go. I can write 5 and 5 on there. Don't think it's going to make any difference. Alice is facing east. So Alice is facing east. And if we remember, we've got never eat soggy wheat bix. All right, she then turns anti-clockwise, so she's facing Bill. How many degrees does Alice turn through? So she's going to turn anti-clockwise until she faces Bill. Now, believe it or not, I think this is a trigonometry question, if we've done trigonometry, or actually, if we know that a triangle, he says, drawing nothing like a triangle, we know that when a triangle has equal side in its right angle, this angle here is always going to be 45 degrees. So actually, as it turns out, how many degrees does Alice turn through? It's going to be 45 degrees. All right, there we go. Getting more interesting. The calculation gives the approximate volume of the dome in cubic meters. Volume equals 1/2 times 4 pi on 3 times 8 cubed. What volume does the calculation give? Oh, I like this question. You literally just put it in your calculator. So we're going to do 1/2 times, I suppose this is just to see whether you know how to use a calculator, 4. So I'm going to try and bring up the pi button on my calculator. Divided by 3, 4 pi times 8 cubed gives me, and what does it want? To the nearest cubic meter, 1072. So I think with this question here, it's just can you use the fractions button on your calculator if you have one, if you're lucky enough to have one, and where does your pi button come from? Okay, and again, another calculator question, quite literally. So I'm going to use my pretty funky calculator. Bear with me, guys. Gives me 21.5. About 40,000 skin cells are lost from the surface of our skin every minute. Which of these values is closest to the number of skin cells lost in every 1 day? So we've got 40,000 every minute. There are 60 minutes in an hour, and there are 24 hours in a day. So if I do 4123 times by 60 times by 24, I get huge number. Okay, so my calculator, now your calculator probably is going to show the right thing. 5, 7, 6, 1, 2, 3, 4, 5. Now, when we're doing standard form, of which this is, I'm going to go 1, 2, 3, 4, 5, 6, 7. So 7 places is times 10 to the 7, and the decimal point falls between the 5 and the 7. So 5.76 times 10 to the 7 will give me this value here. Stopping a distance of cars, 4 different speeds. The rule for the graph, have I got all of this on there? Yeah, pretty much. The rule for the graph is that D is the distance in meters that a car takes to stop when it's traveling at a speed of s kilometers per hour. The graph shows that the car traveling at 60 kilometers per hour takes 30 meters to stop. I use this value to calculate K. All right, so what do we have? So we've got 60 kilometers. 30 is equal to 60 squared divided by K. Well, what I can now do is I can swap these two over to give me that K then is equal to 60 squared divided by 30. Put that into my calculator. 60 squared divided by 30 gives me 120. So K is going to be 120. Dan works for 7 hours at his normal pay rate. He also works, so 7 hours at normal pay. He works 4 hours at double. And he was paid that much in total. How much was his normal pay rate? So what he was actually paid for, 7 hours plus actually 8 hours. Right? Because he worked 4 hours at double pay, he was effectively like earning the same as if he'd been working for 8 hours. So 7 plus 8 is $14.15. If I now do $445.50 divided by 15, that should give me his hourly wage. So 440.50 divided by 15, it gives me $29.70. So let's just check that one again. So 7 and 7 is 14.15. 445.5 divided by 15, we are done. Alex has a rectangular room that long and that wide. She wants to cover the floor of a room with these square tiles. How many packs of tiles does Alex need? Okay, ooh, here we go. So Alex has a rectangular room of 3.2 by 2.4. Now, first things first, we'll notice that's actually given in centimeters. So this is a bit of a trick. So I'm actually going to get rid of the 3.2 and the 2.4. And I'm going to write down that it's 320 centimeters by 240. Now, because you can get square tiles 40 centimeters by 40 centimeters, I'm going to try and work out how many tiles I can get going that way by doing 320 divided by 40. All right, so that actually gives me 8. So she's going to get 8 tiles horizontally. And therefore now do 240 divided by 40. We're going to end up with 6 tiles vertically. So that's now going to tell me how many tiles she needs in total. So 8 times 6 gives me 48 tiles. All right, so to cover her floor, she's going to require 48 tiles. How many packs does she need? Well, it says here that there are 6 in each pack. So if I now do 48 divided by 6, it gives me the great value of 8. ABCDE is a square, BCD is an equilateral triangle, right? So equilateral triangle, what is the size of angle BAC? So angle BAC, so that is going to be this angle here. How are we going to do that one? We wonder. So basically the trick here is knowing that all of these sides actually are exactly the same. So if I look at triangle ABC, right, that's ABC, we know that side there and that side there are exactly the same side length. I can find this angle here because I know that I've got 90 degrees in this corner here, and this angle here is 60 degrees because it's the angle in the equilateral triangle. So I now know that this total angle here is 150 degrees. Because we know that all angles in a triangle add up to 180, I take away the 150, which gives me 30 degrees, and then those two angles there are the same, which gives me 15 degrees. That was a clever question. All right, here we go. What does the missing question mark number equals? All right, to be able to do this, what are we going to do? We're going to try and find a number that are basically in 35. See what numbers I can divide 35 by. So I've got 35, 70, 105. What have we got there? 140. Do any of these values divide by 3 so far? Nope. So we're going to add on another 35. 140 plus 35. Can I divide that by 30? Nope. Add another 35. We're going to get 210. All right, so that's 210, and I know that's going to divide by 30. So I'm going to actually change this one here out of all of them, in fact, out of 210s is equal to plus. So because 210 divided by 35 is 6, I've made the bottom 6 times bigger. I'm going to make the top 6 times bigger, so that's going to become 12. This one here has become 210. So 210 divided by 30 gives me 7. That was a 1, so I'm going to make it 7 times bigger, plus 210. Right, well, 7 plus what gives me 12? 7, 8, 9, 10, 11, 12. That's got to be 5 on 210. Can that cancel down? Yes, it can, because if you notice, we've got to make it a 1. At the moment, it's a 5. 5's into the 5, go once. 5 into there, go 42 times. And there we go. So the missing number is 42. David counts the birds in his garden. 1/3 of the birds were cockatoos, 1/4 were pigeons. He saw 6 more cockatoos than pigeons. How many birds did David see? All right, with this question here, I'm going to do it sort of actually backwards. And I'm going to turn and say, well, okay, let's try and work out whether we can do it backwards. 18. If we see 18 birds, all right, in total, then what's 1/3 of 18? 6, 12, 18. There's 6. And then 1/4 were pigeons. 18 divided by 4 doesn't actually go, because we can't see 4.5. So actually 18 doesn't work in any way, shape or form. So 1/3. So let's now go to the next number and we'll say 24. What's 1/3 of 24? 8, 16, 24 is 8. And 1/4 of 24 is, I believe, 6. So 8 and 6. Is there a difference between those? Nope. So it can't be 24. What about 42? Can we do the same thing with 42? 42, can we divide that by 3? We can, it's 14. And can 42 be divided by 4? I don't believe it can. So 10.5, it's not that one, it must be 72. So let's just check. 72 divided by 3 gives me the great number of 24. 72 divided by 4 gives me 18. And what's the difference between those two? It is 6. Can't think of another way of doing that one, guys. This is the drawing of a swimming pool. It has a shape of a prism. The shaded side is a trapezium. What is the capacity of the capacity of 1 cubic meter is that. What is the capacity of the pool in litres? Okay, so when we are working out a trapezium, he says not drawing a trapezium at all. We know that that's 1, because this distance here is 1, that distance there is 1. We know that this is 2. So that's 2. We know this one here is 12. And that's all I need to do my area of my trapezium. Because what I do is I add the parallels, multiply by how far apart they are, which is 12, and divide by 2. So 1 plus 2 is 3. 3 times 12 is 36. Divide that by 2 gives me 18. So I now know the area of this is 18 square meters. How do I find the volume? I multiply by how far back it goes. So I'm going to multiply that by 5. So 18 times by 5 gives me 90. So we know the capacity of this whole thing now is 90 square meters. But we know that every now that's cubes, by the way, meters cubed. We know that 1 cubic meter is 1,000 liters. So I'm going to do 90 times 1,000, which gives me, strangely, 90,000 liters. That's a lot of water, yo. A cube is cut into two identical regular, try that one again. A cube is cut into two identical rectangular prisms. What is the ratio of the surface area of the cube to the surface area of one of the prisms? Right, well for this one, to be perfectly honest with you, I'm just going to come up with numbers. Yes, a cube is cut into two identical prisms. So that's a cube. So let's make that 2, 2, 4, and 4 if it's a cube. All right, a cube is cut into two identical rectangles. What is the surface area of the cube? We'll find the surface area of a cube. I'm going to find the area of one of the squares and times it by 8, because 8, 6, you muppet. 1, 2, 3, 4, 5, 6. So I'm going to do 4 times 4, which is 16, and I'm going to times it by 6, which is 30. So 16 times 6, which gives me 96. Right, so we're going to say that that has 96 units squared. Now, I'm assuming that the surface area is going to include the bit where they are actually joined. So now we've got 2 times 4. Right, so now I'm going to do 2 times 4 times 6. So 2 times 4 times 6 gives me a total of 48 units squared. So if we now try and do that in terms of units, so what's the ratio associated with the cube? Well, the cube is bigger, so I have to do 96 to 48. And I just so happen to say that 96 divided by 48 is in fact 2. So that's the same as 2 to 1. So there is my ratio. Okay, guys, thank you very much. That's the end of the test, it would appear. Hopefully they've been useful. Lots more coming over on mathsguru.com. Good to see you. Let your mates know that this video is here, and have a good day. Take care. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.